Good morning, good afternoon, or good evening, depending on where you are joining us from. My name is Amaya O'Reilly, and I look after the environmental good practice program at the Energy Institute as part of their technical and innovation work. So I want to welcome you to this very exciting webinar where we're going to get to delve a little bit deeper into a joint industry publication that was developed by Ipieca and the Energy Institute together, which looks at how we can apply circular economy indicators in the oil and gas industry. To the best of my knowledge, this document is certainly a first of its kind, and we hope that the oil and gas industry across the value chain will be able to use it to either begin to implement or increase its circularity across its processes and products. We're going to start with a really quick intro to the Energy Institute and Ipieca remits, just so you know which organizations have produced the work and what we do very briefly. And then we'll hand over to KPMG we've got Aglaia Fisher on the call, who was part of the KPMG team that produced this guidance document for us. And she's going to get into all the interesting bits in terms of what the guidance is all about, how the indicators could be used and what those indicators are. Then we'll hand over to Michael. So we've got Michael from SLB on the call as well. He was part of the steering group, and he's going to talk through a case study example of how you could apply these indicators or how he could apply these indicators to his activities within his organization. And then we will finish off with a Q&A. I will mention in a second a couple of housekeeping rules after we've done the EI Ipieca introduction and let you know how you can access the Q&A function to ask those questions. So next slide, please, Amy. Firstly, a little bit on the Energy Institute. So the Energy Institute is a chartered professional membership body for people who work across the world of energy. And our mission is to create a better energy future for our members, society, and society by accelerating a just global energy transition to net zero. And we do this in three ways. So the first is around developing the future energy workforce. So we have our EI Academy that develops and hosts training. You don't have to be an energy whiz kid to access this. There really is something for everyone, depending on what stage in the energy journey and your energy career you are at. We are also, of course, a chartered professional membership body. So you can apply for various charterships through the Energy Institute. One that might be applicable to people that are on the call today is applying to become a chartered environmentalist. So that's something that you could look at too. Our second focus then is around bringing together expertise and advice. So one of the things we do is we develop and host lots of events. One that you may be familiar with is our flagship event that happens once a year, International Energy Week. The next one will be in 2025, between the 25th and 27th of February at the QE2 Centre in Westminster. So it's going to be an even bigger event than we've had previously. And really that week is all around having really interesting panels, discussions and roundtables on technologies, business models and skills that we need to get to net zero. And then our third focus then is around supporting industry operations. And this is really where the technical innovation program and department that I sit within begins to flourish. So our technical and innovation program, through collaborating with industry, regulators, academia and wider stakeholders, is really there to develop a wide range of standards and good practice materials to ensure industry operations are sustainable and efficient and safer going forward through the energy transition. And this guidance document today that we're going to talk to is an example of one of those pieces of good practice that our technical and innovation program has developed. In order to kind of, I suppose, access that program, of course, we have membership options there. Your organization could become a technical partner or a company member, and that will give you first-hand access to those interesting dialogues and ability to kind of steer the work and the good practice that we develop. Christy, would you like to introduce Ipieca quickly?
course, my name is Christy Lowe. I'm the nature manager of Ipieca. So Ipieca was formed in 1974 following the launch of the United Nations Environment Programme as the key interface between the oil and gas industry and the United Nations. Initially, we only focused on environmental and climate issues, but in the past 50 years, we have expanded to also bring the industry together for social and sustainability related issues. Importantly, we are the only global sustainability association covering both the upstream and downstream of the industry, and we provide guidances across the whole project life cycles with full industry value chains. So in 2021, we have updated our vision and set out a new strategy, which is the one that you see and printed on the slide. And in this update of the strategy, we have strengthened the sustainable development aspect as well as the energy transition aspect. And to support this new strategy and vision, we also have 4 strategic pillars, which includes climate, nature, people, and sustainability. So that's Ipieca in a nutshell. If you want to know more about Ipieca, please do let us know. Thank you.
Thanks, Christy. So just some housekeeping rules then really quickly before we get to the exciting stuff. So just to let you know, this webinar is being recorded and it will be made available on the Energy Institute's YouTube page roughly a week after the event. We're also going to have links from the Ipieca site. So if you're an Ipieca member or you use that site regularly, then you can also access it through there. And of course, anybody that's joined today will receive that thank you for joining email, including a link to the recording as well. So you'll be able to access it and share it. All of you should be muted except for the presenters. I had a quick check and it looks like you are, but that means if you do want to ask questions, please use the Q&A function that's at the top of your screen to ask those, and we'll have 10 to 15 minutes at the end to try and address some of them. If you can, try and remember not to post them in the chat, just because we will be looking through the Q&A bit and I don't want to miss anything that you'd like to ask. So without further ado, I'm going to hand over to Aglaia, who's the Circular Economy Advisor at KPMG, and she was one of the key pillars in producing this guidance document. And she's going to walk us through and give us an overview of the publication and what it could do for you. Thanks, Aglaia.
Thank you, Maya, and yeah, very happy to be here. It was quite an interesting assignment when my team and I started to do this work. We've been focusing on many topics in circular economy and also indicators and measuring, and then to apply this to oil and gas makes it very specific and tangible. So that was a really interesting exercise. If we can go to the next slide, please. What I will talk about is first we go back to the start to do a very brief introduction to the project and circular economy. So, you know, what are we looking at? Then I will go through what we did in this paper and also the logic that we followed to talk about the circular economy indicators for the oil and gas industry. And then finally, there are some next steps and developments. And in the end, we have room for questions and answers. And next slide, please. Yeah, so this is the first part about the introduction to the project itself and circular economy. So we can move ahead to the next slide, which is essentially an overview, and maybe, yeah, we can click to get the whole figure inside. Sorry, last one. I wasn't aware this was clickable, sorry. Yeah, this is a good overview to give. This is how we visualize the circular economy. It's called the butterfly model, and essentially this model was created by the Ellen MacArthur Foundation, and it really visualizes how in a circular economy you ideally see products and materials cycling through the system. And on the left hand, you see the biological cycle. So these are all the products and materials that can go back into the soil to serve as feedstock for a new growth cycle. And on the right hand side, you will see the technical materials. And yeah, these are materials like metal or concrete or stone, or all the things that, yeah, ideally we keep in technical loops, but we don't put them back in the ground. Yeah. I think it's good to mention that with circular economy, the aim is really to eliminate waste and pollution, to circulate products and materials at their highest value for as long as possible, and to really increase efficiency. And if you look at these, yeah, these circles or these loops, so to say, it's really important to to keep in mind that we're not just talking about recycling, which is very important, but it's only the last loop. So we're really looking to design also in different ways, to design products, materials, and assets that can really be used longer, be used more effectively. And in that way, we kind of slow the metabolism of using resources. And that's what circularity is all about, through different strategies to keep as close to the initial product as possible, and to keep that value and use it for as long as possible. If we continue now. Thank you. The goal of this publication was really to conduct a literature review and really evaluate the existing methodologies, tools, and guidances that exist, and assess the existing gaps for measuring and implementing of circularity in the oil and gas industry. So with this goal, we had a few objectives. We wanted to evaluate the existing frameworks and tools. And we wanted to do this across the oil and gas supply chain and summarize the available knowledge and existing gaps. So this would mean to make a long list first and then a short list of indicators. Then to provide recommendations on how to implement, measure, and monitor for select indicators. And also to identify some limitations and gaps to measuring circularity in the oil and gas industry. Another objective was to identify 2 to 3 key frameworks or sets of indicators that are most relevant to be used in this industry. And we have started out initially with 6 frameworks, and we have looked how much they were already used in oil and gas, also what kind of data needs they would imply, and also how different they were. So also because we saw that several frameworks had different perspectives, and we think we needed those because we found that there was no one framework that could be the one and only to use. So we decided that we would present in the end 3 frameworks that are really compatible and will reinforce one another. And we've selected for that reason 3 frameworks, and I will go into those 3 a bit more and how they're used. Next slide, please. Now, before we really went into the frameworks, we thought it was good to, together with the steering group that supported during the trajectory, looked at what does really this oil and gas value chain look like? What are key assets that we can identify for up, mid, and downstream? So if we want to apply the concept of circularity, which can stay very conceptual, we need to really put it on the ground, so to say. And if we can go to the next slide, please. We have an example of what that looks like. So the main assets for upstream, and we can show the other part of the slide as well. Yes, thank you so much. So these are an example of key assets for upstream. So really for the exploration and production phase. So you see, for example, assets like drilling rigs or drilling tools. In production, for instance, you see offshore platforms, logistical equipment. So this is really to give a bit of tangible examples of, okay, what are we actually talking about? Next slide, please. Now we can also look at the key materials. And this is an example still of upstream for exploration and oil and gas production of inflows that we've divided into consumables and durables, outflows, products and waste streams, and some critical materials involved, because we thought it was also interesting to really have a bit of a sense of what critical materials are used. This is just to give an overview, but really to make it a bit more tangible. What are we talking about? What materials and products are we talking about? Okay. Let's go to the next slide, please. Now, if we talk about these indicators and indicator frameworks, this is the following part, and we can go to the next slide. We see when comparing, we have compared between 3 frameworks. The first is the Circular Transition Indicators Framework, and this is a framework that was developed by the WBCSD, and actually KPMG has played a role also in the development of it. This is a framework, it was the initial first framework to really start to measure circularity when no one else did yet. So it is and it has been further developed in the meantime, and at this stage it's also being developed specifically for certain sectors, so to make it more applicable. The second framework we have looked at is Circulytics. This was developed by the Ellen MacArthur Foundation. And this framework, it really enables measuring on an organizational level. It's a bit more high level, and it has more qualitative metrics. The last framework we compared was the ESRS, so it's the European Sustainability Reporting Standards, E5. That is a chapter under the CSRD reporting framework, which is specifically about circular economy. And here a pro is that there is really clear connection between quantitative and qualitative metrics. It elaborates on waste reporting with a breakdown of waste recovery operations and including specification of hazardous waste. So this is a bit of a different kind of framework because this is a reporting framework, whereas, for instance, where both CTI, circular transition indicators, and Circulytics are more measurement frameworks. And with the CTI, a strong point is that it's very widely applicable. It's quite a well-known metric, which is used throughout many different industries. And it also has different modules to allow to integrate, for instance, critical raw materials or different recovery types or water circularity. So there's kind of a pick and choose model to use, but inflow and outflow would be the main body of this framework, and that would also be quantitative. So maybe that was a bit about how they compare. They also all have some downsides. So a downside of CTI is that it's quite quantitative and you need quite detailed data. So that can be a challenge at this point because sometimes that data is not yet available. There's less focus on qualitative metrics, whereas these are important for steering on a higher level. So that's, for instance, where Circulytics is stronger. But then if we go to Circulytics, then the questions can be sometimes broad and they must still be translated in metrics. And another issue or given, let's say, is that this framework is discontinued. So Ellen MacArthur Foundation has decided to kind of more join forces with the other existing frameworks and is not continuing this anymore. About the ESRS, the challenge is that there is often no methodology given for calculation. So this is a reporting framework, but how to report on it sometimes stays a bit vague. It includes metrics relevant for oil and gas, but that still has to be developed. And actually, that is now in development, so that is coming. Next slide, please. So maybe to put it shortly, we found that there was no one framework able to cover all the circular measurement needs of the oil and gas industry by itself. And therefore, relevant qualitative and quantitative circular economy indicators were identified based on these three frameworks. We can go to the next slide. Now, to start off with the qualitative indicators, they were primarily identified with Circulytics and ESRS E5. So what we see if we look at those is that with Circulytics, there are topics about strategy and planning, innovation, people and skills that we'll provide a bit in the next slides, an example on. That's why they're both actually, but also operational enablers and external engagement. But also for E5, there is topics like policy, actions, and targets that they asked to review. Next slide, please. This gives a bit the overview of these qualitative indicators and where they can be found. And you see that there is not really that much overlap between the two frameworks. So these ones are really complementary, where ESRS is really focusing on policy, actions, and targets. You see that Circulytics is more about the strategy angle, planning, some innovation, people and skills topics. Now, I'd like to zoom in even one level deeper and give an example for both. If we go to the next slide. So for the Circulytic example, actually, we took the example of external engagement, so the engagement with the value chain. This overall topic is about key circular sub-indicator for the oil and gas Circulytics based on the survey questions of Circulytics. And if we look, for instance, at the first question, so the extent of engagement with suppliers to increase sourcing based on circular economy principles, and this is really a question, and then the response ranges can, the responses can really range from no interactions involving circular economy as a topic, but also supplier requirements based on circular economy principles. And those are usually specified in contracts, and if they are in place, they should be ranked. So this is more a ranking exercise and to look at a bit of a high level, to give a bit of a high level overview of the engagement. Next slide, please. The ESRS E5 example is about the 3 points of policy, actions, and targets. And for all these 3 topics, oil and gas company should give a description of their circular economy policy, the relevant actions and targets that follow the policy directions. So this is very, it's qualitative as it asked for a description and gives more information on the direction that the company takes and policies that are in place. Or not yet, potentially, of course. Next slide, please. Now we go to the quantitative indicators overview, and this is a bit the full overview, so to say. And you see, if you look at the right-hand column, that there are some overlaps here between the CTI and the ESRS E5 framework. These are really about the quantitative topics of material inflows, material outflows, also some part of design, which is about, for instance, a percentage of potential recovery, and other topics like water circularity or anticipated financial effects as asked by ESRS E5. And you see already on the right-hand side that for ESRS E5, there is some oil and gas industry specific indicators, which are, I believe, also published in a consultation draft last June. So that really goes into specifics for the oil and gas industry relating E5 reporting. Next slide, please. Now this is a CTI example, and this is the example of the percentage of circular inflows and the percentage of circular outflow for a Christmas tree. And this is obviously not the celebrative Christmas tree, but the asset to be used in oil and gas. If you look on the left-hand side, we see the inflow. This is based on the formula that is given in CTI. So the CTI guidance can be downloaded online, and it has formulas for how to calculate these different things. But essentially what it is circular inflow is the sum of the renewable content and the non-virgin content. So in this case, it is 30%, and renewable has to do with organic matter. So that would be the biocycle of the butterfly chart, if you remember. And the non-virgin content would be the technical cycle materials that are non-virgin, so are recycled or reused. In this case, it's recycled steel. On the right-hand side, there is a percentage of circular outflow for a Christmas tree. And here the calculation goes a little bit differently because this is a multiplication of the percentage recovery and the actual recovery. So in this case, it's 60%. And the reasoning behind that is you can have a recovery potential if you design something in a very modular way, that it can be taken apart in a good way. But in the end, if it still ends in landfilling, for instance, then it is not circular in reality. So that's why this formula works a bit different. But this is just an example of how to calculate inflow and outflow, circular inflow and outflow. And what is also good to know is that E5, as I have told, they present the they don't present really a methodology to measure, but they ask for inflow and outflow, and here they refer to other frameworks such as CTI for measuring. So in that sense, it could be reinforcing one another. So the E5 will say, at least for European markets, how reporting should be done, and then a framework such as this can be used for making the calculations. Next slide, please. This is another example of recovery percentage recovery type indicator. So this is still CTI. This was for a choke manifold. And what's interesting to show here is that with recovery types, you see the different recovery types. So you can reuse, refurbish, remanufacture, and recycle. And then we get to the more linear types of landfill, mixed waste, of other unknown, but at least not reused. And then the percentages on the right-hand side. So if we look at this, we can actually see that this is quite a circular asset, because quite a lot is refurbished and remanufactured, and also some recycling. So this actually looks quite positive. Let's go to the next slide. This is an example of E5 and very specific for that framework. It's about waste reporting. What you see here is the total amount of non-hazardous waste recovered and the total amount of non-hazardous waste directed to disposal. So this is really in tonnage, and this is how in E5 it's categorized. What is interesting to note is that because this is a reporting framework, the waste topic falls under E5. So the circular economy E5 topic covers everything regarding product design, but also inflows and outflows. And then of course, waste is part of that. Interestingly, when developing circular economy measuring frameworks, waste was traditionally not really part of it because it was assumed that, waste is linear. So it kind of stayed a little bit out of scope. So it's very interesting to see now that because in E5 waste is included, that this kind of makes the picture complete. So that's an interesting dynamic to see. Next slide, please. So maybe zooming out a bit again, I've just showed quite detailed some examples of how measuring circularity in oil and gas can be done, and also what framework can be used. What are some advantages or disadvantages of frameworks, and also to give some specific examples of then what can be measured and in what way. Key takeaways are that this is really a value chain effort. So in that sense, circularity and understanding what resources and products go through the value chain cannot be done by one entity. So in that sense, it really demands also more integration and connection to your value chain, both upstream and downstream. If we look about in upstream, then it's really important to design modular assets and to really minimize waste throughout this production process. If we focus on midstream, we see potential improvements of circularity by more repurposing and adapting existing infrastructure for the future. And potentially this could even be repurposing for renewable energy, also, of course, depending on whether technologies can be reused or how easy it is to reuse structures for renewable energy. But to really use and optimize resources to, by repurposing at the highest possible value. And downstream, we see that it can be really an opportunity to increase circularity by developing recyclable products. So integrating also non-fossil fuel materials, also designing processes that support long-term sustainability and resource efficiency. Maybe it's good to mention that we did take kind of a cutoff point when the products are sold. So we have, in that sense, not really looked at the application of petrochemical products for instance, plastics. So in that sense, we kept that out of scope in this study. Now, if we look at design, engineering, and construction and decommissioning, we also looked a bit at these topics, which are quite essential as a perspective to also increase circularity. With design and engineering, you can prioritize circularity by incorporating modular long life designs, also enabling future adaptability and ensuring early stage decisions to support sustainable material flows and recovery. And with the construction and decommissioning, it's really also to focus on modular design and design for disassembly and high value reuse. Now, if we talk about circularity of assets, we venture a little bit into the built environment as well. And there are quite a lot of frameworks being applied, like Cradle to Cradle and BREEAM, to measure circularity and enhance circularity in construction. So that's also something to keep in mind. If you really look at assets and buildings, then that would be a perspective to take. And finally, to talk a bit about circular enablers for measuring circularity, we flagged that procurement is important to really procure in such a way that it enhances circularity and it enhances lifespan extension. So to really take into account life cycle considerations into procurement policies, potentially also in contracting, and to set the right KPIs and track that to measure that circular inflow and performance. And finally, information technology to leverage real-time data and Internet of Things to optimize operations. So this is also to streamline circular practices, but really to set also KPIs and track the impact, track resource efficiency and circularity. This can also be done by preventive maintenance, for instance, to really use information technology to optimize the asset lifespan, so to say. Thank you very much. I hope this gives a bit of an overview of what we've done. And yeah, please, by all means, ask your questions. Oh, sorry, I forgot the last part. Yeah, let's go to the next slide, because there are some developments which are still ongoing. Circular economy indicators, it's still really an emerging field. So there are some ongoing developments. First of all, Ipieca is really exploring development of a compendium of case studies and to really update their sustainability reporting guidance. Then the European Commission is developing an oil and gas sector specific standard for CSRD. That's the one that has come out in June and is now up for consultation draft. The WBCSD is further developing the circular transition indicator framework, but also does this as a broader endeavor to develop a global circularity protocol to really show the ways to help companies to select the best frameworks and measuring and guidance tools for really increasing their circularity and driving circularity by sound managing and measuring. And the Energy Institute is developing recommendations to overcome the barriers to circularity and then across the asset life cycle. So these are some things that are ongoing. So more to come. Thank you very much. And I think I'll hand over to Michael for the case study.
Yeah, go for it. So thank you so much, Aglaia. That was really, really interesting. And I'm sure we'll get lots of questions off the back of that. Just to remind people, if you do want to ask questions, use the Q&A function at the top and we'll get to them in the last 10-15 minutes of this call. But yeah, let's hand over to Michael. So Michael is the Well Construction Repair Champion for SLB, and he has joined us today to talk through their ongoing efforts to try and embed some of these indicators from the good practice into their activities and processes. So over to you, Michael.
Thanks, Maya. So yeah, I was part of the working group for this study, and really my interest was much more at a granular level. So my job role, focused very much on maintenance, turnaround time, life extension of the assets that we manage for well construction. And so I'm really interested as part of that. We need to optimize our circularity, extend our part life, reduce our waste, and to do that, we're looking for a number. So I was looking to really create something granular. I wasn't looking, that was my interest in this study. And I took from the recommendations from the study, the CTI circularity indicators were definitely the most granular. It gave reasonable recommendations on how to manipulate those numbers and to actually come out with a percentage circularity. So that's what I used in this case study. This is a very simplified case study. I took a drill collar for one of our high running product lines, which is a well mature product line. It's a single part chunk of material, so it's an easy one in the grand scheme of things for this modeling, but I wanted to know how those numbers would look by actually when we actually put them together. So using the percentage material indicators from CTI, I looked at the material inflow. It's pretty straightforward. Through that time period, we'd purchased 142 assets manufactured by a third party. Going down to the material, reaching out through supply chain, we got feedback that 40% of that material was from recycled content of that material metal. And so that gives us a baseline. It gives a pretty straightforward split of virgin content to non-virgin content or circular content. And that, I think the next step at this point would be to implement the requirements for reporting that with our suppliers, and that will enable both our suppliers to give us those answers, and for us to be able to use that as a comparator in our supply chain. The other side of this is the material outflow. So through this same time period, this is where we have, my team and the function I work with has much more control, much more we have much more control. We're much more involved in how we split that material. So through that period, we remanufactured 20 collars. So that's sending them and using that raw material in its current form to remanufacture other parts, smaller parts, generally remachining. Through that process, we lose about 50% of the material through that machining process, but we retain 50% of the material is in its current form. So it's a very direct value flow. We also recycle further 36 collars in that period. There, from a circularity material perspective, we get 100% circular flow, non-value content. Goes straight to a third-party recycler who, they're going to utilize this directly. It's pretty clean material. And then there's a certain amount of landfill through the process that's a struggle to avoid, though we definitely can do more. We do make a lot of attempts here, but this is seen as, full non-virgin content. It's lost and can't be recycled or remanufactured. So our total outflow of 91 collars through this period, we have a split of virgin to non-virgin content, what's circular, what's not circular, what's virgin, and what is circular, what non-virgin content, which gives us an overall circularity of 55%. What was interesting here when we look at this and the actual circularity we get on the math side, what these numbers are showing us on the outflow is that really we should be channeling everything to recycling. So we should avoid remanufacture. We're only getting 50% circularity, and we need to tackle our landfill, our lost in whole, and try and recycle everything we can. What flags to me there is that we know that the value and the circularity and sustainability of recycling is pretty low. There's a huge amount of material processing to return that recycled material back into the value stream. So although we retain that material, it's not necessarily the most sustainable choice, and that's something that I'd certainly worry about in utilizing these indicators as they are. So we go to the next slide, please, Amy. So at next level, I tried to model this based on value to try and understand if we could maybe look at this from a different perspective. So here we're going beyond the CTI indicators, but we're using their baselines. So the left-hand side of this table is exactly the one you just saw. So here you've got it's just material outflow, the process account, virgin content by weight, non-virgin content by weight, and material circularity, 55%. These next three columns is what I've now added. So now I'm looking at the value of those items, those assets. Consumed value, so what was lost, recovered value, what we retained, what was circular, and a value circularity indicator based on that. And so here what we can see comparatively, if you look on the remanufacturing line, we're able to retain 50% of the original value by doing that remanufacturing directly from those parts. So we're still holding that 50% value circularity versus material circularity. For recycling, the value retained is around $900 of nearly, $1.2 million of assets. And so your value circularity for recycling, which I think is much more aligned with, actually how sustainable this process is, given the amount of processing that then has to take place, is much, much lower. Landfill is the same, everything's lost. That's the one we want to avoid. That's the direct linear economy that we need to tackle. So our total circularity, if we look at the value side, is only 11%. And I do think that's a very important thing to look at. The material circularity indicator is very much agnostic. It doesn't take into account value. It's we don't, from a circularity perspective, look at sustainability, but I think the value is very much aligned with that. And looking at material alone risks suboptimal decision making from both sustainability and a business angle. So we can go to the next slide, please. So looking overall at the challenges we faced, I think one part was the business model. So I work in most of or a large portion of well construction is a service type business model. So these closed loop indicators, the inflow and the outflow, they do give good granularity, but they don't account for extension of lifetime, so they're missing quite a big chunk of the vision for a service business model. The other challenge I found was data availability, which was mentioned before. So part and mass quantities really were not available in our business systems. This is something we're trying to tackle. It's not going to be something that's going to be solved tomorrow. Hopefully in the next 6 to 12 months we can start to get some better answers from that. But this is a very new thing that we're pushing as we're trying to create these circularity KPOs. On the other side, the value side was actually reasonably practical. We have good tracking, as I think probably applies to many businesses. What we do, what every business tracks very closely is the values, the flows, the financials. And so this was something that I could put together reasonably quickly. There's definitely going to be some confidentiality questions, but actually on the publishing side, the circularity indicators are all percentages. So I think this is something that companies could use to publish results relatively quickly and quite accurately. I think one of the big risks I saw was this issue with the material indicators not really allowing for the value of the different loops. And I think the value of different loops really impacts the sustainability of those loops. And so that's going to be something that we need to look at. So on the insight side, for service models, for a lot of companies, we're going to need to expand the indicators we use in CTI. So the optimizer loop indicator, I haven't gone into detail here. I did look at it. But in the 10 minutes of this presentation, it would have made a lot more to explain. But they're going to be critical to ensure we're getting comprehensive modeling for the company. And to be able to look at both the value or suggest the value, maybe there's some better options, as well as the material circularity is going to be key to be making the right decisions for the organization and the right decisions for circularity, and also to push the right business models and the right behaviors through the different functions in any company. I mean, on the important side, there's no doubt that these KPIs are going to be absolutely vital for aligning companies, increasing their sustainability, their circularity, and we're making a big push to carry that out, which is where this case study came from. I think the CTI methodologies, from what I saw, was the best available, but there are risks with using it, and we need to make sure we're understanding the value of the different circularity loops and how that impacts when we're implementing these indicators. So that's with that, I close out. Thank you very much. I'll look forward to lots of questions. I'll hand back over to Amy and Amaya.
Thank you very much, Michael. That's great. It's also great to have somebody on the call that's able to talk a bit about how the indicators are being implemented or trying to be implemented within your own organisations. I think that would have been really interesting to everybody. So thank you for joining us. We are going to move over to the Q&A. So I can see there's a couple of questions in the Q&A function, which we'll start with, but please feel free to add to them as we go through them. And I'll try and direct them at the right person. I think there's some for you, Aglaire, some for you, Michael, and then Christy and I will add little bits in if we've got anything additional to say, if that's okay. So starting with the first one then from Nadia Borelli. She's asking, did you consider the new ISO 59020 framework? Why was it not selected nor mentioned? Thanks. So I'll hand it over to Aglaire, but I think something to just start with saying is that framework came out earlier this year in 2024. And I feel like at that point we were already closing off our piece of work, but I don't know, Aglaire, if you've got any comments on that piece of work or how it could be incorporated into what we've done today.
Yeah, thank you, Amaya. And indeed, that was still very much in the making. So it was a bit difficult to incorporate it at that time. Of course, at this moment, we're really looking into that as well. With the ISO standards, what is a bit difficult is that it is behind a payment wall. So ideally, we would want to have a framework that is available to all. And I believe this is also something that the ISO is considering. So so for that reason, it was not yet included. But of course, a very, very important framework that we're definitely looking at. And frameworks that are currently being further developed, like CTI, but also in ESRS E5 are, of course, also looking at those ISO standards.
Thanks,
I
Claire.
will also add that Ipieca has ISO-related webinar that is specific to the ISO 59000 series on circular economy. So if you're interested and if you're an Ipieca member, you're more than welcome to go to our members area webinars page, and you can rewatch the webinar on ISO norms related to circular economy and ESG reporting. Thank you.
Thanks. Michael, I saw you unmuted, so I didn't know if you had anything additional to add on this. I imagine not.
Not on the ISO one, no.
Perfect. Okay, so let's move on. So we have another question then from Jimmy Permadi. So this is probably more at you, Michael, and it's around the impact on operational cost regarding the circularity implementation. So you obviously mentioned and you showed in your graph some of the consumed and recovered kind of values, but this question was around elaborating the impact on cost or operational cost regarding the circularity implementation. So I don't know if you just want to summarize a little bit again.
Yeah, of course, so happy to. So I think this is a question that comes up a lot in all sustainability, circularity chats is, how much is going to cost us? Is this, are we going to affect our business? My original role, I've been in this role since 2019 and was very much, I was put in the role from a perspective of cost of service delivery for the organization and from a perspective of turnaround time, tool availability. And it has flowed directly into circularity, life extension of parts. It's very much aligned. And I would argue from the experience I've had is that if you're making a decision that is not a good business decision, you're probably not making a good circularity decision. The inclusion, the avoidance of waste and the inclusion and extension of the value from the material that we're utilizing should align directly in most cases with reduction in operational cost. So yes, that would be from my experience. I think circularity is, the benefits of circularity are both environmental and for our nature impact, but also by increasing our circularity, we should be improving our business case. And that's a big part of being able to, sell it to an organization and implement those principles. They're the right decisions to make.
Thank you, Michael. I think there's something definitely here as well around long-term returns, immediate costs and long-term returns when it comes to things about circularity and the benefits being felt a little bit later down the line as we kind of transition. So perhaps the way that we're also measuring, the economic costs in terms of the timeline of them is something to consider within this realm as well. Aglaia, Christy, was there anything you'd like to add to that one? Perfect. Thank you. So another question then from Fernando. So I think anybody could really jump to this, but perhaps we'll start with you, Aglaia. So does the concept of circularity have any similarities with the life cycle approach, such as for fuels?
Yes, I hope I understand your question correctly, but I'm assuming you are now aiming at the LCA approach, so life cycle assessment approach of creating of the whole life cycle, so really to create fuels, but also up to use. And that would be to measure the environmental impact. So that I would say that's another lens. So the concept of circularity has similarities, but it's a bit of another lens, because with circularity we look mainly at the use of products and materials and how well and long they can be used. So it is more of a material focused approach to reuse materials, but also slow the whole metabolism of material use. Having said that, the two are emissions and material use are partially overlapping, because if we can slow the metabolism, then we have to mine less resources, and that will also save emissions. So in that sense, we can also talk about avoided emissions, which is sometimes referred to as scope 4. But yeah, I would say in that sense, it's it's definitely related, but LCA is more focused on emissions, and circularity is primarily focused at material metabolisms.
Thanks, Aglaia. Mike, is there anything you want to add to this in terms of your experience?
Yeah, probably not. That's okay. I'm not. I very much. Sure. I'm on the service side rather than the product side. So I mean, I could have an opinion, but it probably I will leave this one.
All good. Just trying to be inclusive. Okay, so I actually had another question, Aglaia, which I think is quite interesting. So obviously you encounter data gaps when you're trying to implement these circular economy indicators. And do you have any suggestions of how you could overcome this barrier, these data gaps, for instance, throughout the value chain or in diverse geographic regions?
Thank you, Maya. That's indeed a good and complex question or topic, because we see that we're just scratching the surface when it comes to measuring circularity. We have seen how emissions are measured and things. That has become really a measurement, but also a currency in a way. And when we talk about circularity data, there is so much to talk about. And we see that when companies start to measure circularity for the first time, it depends a little bit where they find themselves in the supply chain. So if they're close to actually the mining or the more raw resources, virgin or non-virgin resources, then it becomes a bit easier, because then usually they have more insight on what is in the materials. But when you go to later stages in the supply chain, to the OEMs, for instance, that becomes harder, because then you have a lot of suppliers that supply to you, but how to get all the data from them. So in that sense, we see that there is challenges within the supply chain, and for that matter, it's important also to engage with your supply chain, because often you see this kind of waterbed effect, that if you would have more transparency, more information from back in the chain, it will have a tremendous effect in another stage in the value chain. Now, that's not really a solution yet, but something that points towards more engagement with suppliers. And also what we're looking at is we're also looking at circularity data exchange. So data exchange specifically for circularity. This is actually also a topic that the WBCSD is working on, and we're supporting with, and it's quite exciting, but very complex and still in its infancy, to really look at how can we, first of all, what is relevant data if you talk about circularity? So what data would you want to go back and forth in the supply chain? And then also, how can you enable that data flow? And that also has to do with interoperability between different systems. So the data aspect at this point is still, it's still really a challenge. But the good news is that there's a lot happening, and quite some cases and companies that are really starting to work on this. For instance, the car manufacturing industry is quite far. So these would be also the examples that with a bit of tweaking can be learnings also for the oil and gas sector as well.
Fantastic. Yeah, I think we always forget there's a pool of other knowledge within other sectors that we can tweak and apply to our own operations and processes. So that's great. Thank you very much. Also, just to add there, in partnership with Ipieca in Syria, we are developing a piece of work at the moment which kind of looks, it's around embedding circularity across the life cycles of assets, including offshore oil and gas platforms. And we're really trying to understand the drivers and enablers for circularity, the barriers, and then provide a set of recommendations of how to overcome them. So that might also be an extra piece of work that helps to fill that gap in the puzzle.
I mean, I would say that data availability question is a very instant one that I saw when trying to apply these indicators. And I think integrating it into supply chain, so you're pushing, the suppliers that you have as early as possible, and getting your own systems up to speed are going to be really key, because this is going to be a question the whole organization is going to be asking, and it's a question that clients are going to be needing an answer to. So yeah, the earlier you start that process, the better. It is not simple.
Absolutely. Yeah, really important point. Whilst you're speaking, Michael, we have a question for you. So that's just come in from Janina. So Janina says, for someone who doesn't work on the operational side, can you give examples of what remanufacturing looks like in practice, Michael? Is it always clear when something can be remanufactured and when something has to be recycled, keeping in mind the differing value retention?
That's a good question, very applied. So it is not clear. I mean, from our organization, we're now trying to map that. So remanufacturing, the definition of remanufacturing is to take a component and make another part number out of it, so a different part number. That can be applied, you know, in a variety of ways. I guess it could be a different version of the same item, but from our application, typically it is a completely different part, much smaller net shape. So you're taking that original bulk of material and you're remachining it into something that's smaller, you know, bolts from a saver sub, or, you know, whatever it is. As far as is it clear when it can be remanufactured, we have published an internal company guideline on how to remanufacture. You know, there's a lot of questions around material aging and things like that, which we've had to answer. We needed to risk evaluate, risk reduce, and it is not clear. What we're trying to do now is, where we have put that effort in and found remanufacturing opportunities, is to now make that visible. So when we're scrapping something, a particular part, you know, we can say, okay, well, there's some remanufacturing options. We're also trying to make clear, even on the recycling side, it's not always easy. The language that the recyclers talk versus the language that our SLB technical people talk are quite different. You know, they might be referring to nickel alloys, whereas we're talking about Inconels and Itronics. You know, although actually just getting that categorization and getting it to the people who do recycling, the people who do recycling are not material experts. We need to be able to have a map of the part numbers, the material, and the optimized recycling allocations, in the same way as we need that map of remanufacturing opportunities. And it needs to be at the hands-on end of the organization, so those decisions can be made by the people actually taking a part that they no longer need and putting it in, you know, the bin, hopefully not the recycling bin, ideally putting them back in stock to be used as remanufacturing feedstock, you know, would be the aim, you know, once we can no longer repair. So it's all work. And I think that's one of the reasons, again, circularity is the right business decision to make. And a lot of companies do a lot of circularity from a perspective of maintenance, but there's a lot of work to be done to optimize all these other loops. Sorry, maybe I've taken too much time with that answer. I hope I've answered your question.
No, perfect. Thank you so much. I'm going to squeeze one last question in, just a quick answer, and then we'll wrap up. Iglesias, this is going to be for you. So somebody's asking about why volume crude oil traded is an important indicator listed, and it's obviously the indicator that's listed in the ERSS oil and gas specific guidance.
Yes, that's indeed a specific indicator, and it is. I just looked it up. Also, I had it open actually on my computer. It is in the E5 circularity topic. It's actually topic number 78. You can definitely look it up. I like the question because you're referring to volume crude oil traded, and maybe that could be a competition law issue. I think competition law is a very important concept and also could be very hampering to the circular economy transition, because what we see is that we want supply chains to integrate more and to exchange information. We even want sometimes competitors to collaborate together on a topic just to share the burden of transition costs and figuring it out. So there is some friction between current competition law and doing the developments needed in general, not just for the oil and gas industry, but I agree that maybe it could be an issue, but it is asked under that topic.
Thank you, Aglaia. Okay, so let's wrap up. So just say thank you to everybody for joining. Yeah, thank you, Aglaia, for joining and presenting. Thank you, Michael. Thank you, Christy, for the great partnership with Ipieca. The report is available to download freely from the Energy Institute's and Ipieca's website. There's a QR code there. And yeah, there's lots of good work to come, so stay tuned and look out for the recording and the slides that come after. Thank you very much, everybody.